The Earth has a magnetosphere, which is a system of magnetic fields. It is a comet-shaped system that deflects charged particles that come from the Sun, thus shielding our planet from harmful particle radiation and preventing solar wind from eroding the atmosphere of the Earth. Solar winds are a stream of charged particles released from the Sun's upper atmosphere. Past research have gathered substantial evidence of the effects that solar winds can have on Earth's magnetosphere. The impact of solar flares. Solar flares are sudden eruptions of electromagnetic radiation from the Sun. However, this is poorly understood. Solar flares are highly explosive events that can last from a few minutes to many hours and can be detected using X-rays or optical devices. Researchers recently carried out a study investigating the effects that solar flares can have on Earth's magnetosphere. It was determined that they gathered some valuable information that could pave the way towards a better understanding of geospace dynamics. Geospace, which is the portion of outer space that is closest to our Earth, includes the upper atmosphere, the ionosphere, and the magnetosphere. The ionosphere is the ionized part of the atmosphere. The magnetosphere is located in the region above the ionosphere and is the fully ionized space region above 1,000 kilometers up from the ground. The region is surrounded by the solar wind and is affected and controlled by the Earth's magnetic field and the solar wind's magnetic field. The magnetosphere is generally described as Earth's protective barrier against solar winds and other solar particles, as it prevents these particles from entering the planet's other protective layers. Despite this, studies show that when the direction of solar wind is opposite to the magnetosphere's magnetic field, magnetic lines from these two regions can connect. This indicates that some solar wind particles can be directly transmitted to the space surrounding Earth. Many have asked, what about the flare process, which is characterized by enhanced radiation not only directly affecting the Earth's ionosphere, but also causing disturbance in the magnetosphere like the solar winds. Researchers have looked at a series of observational data sets that they collected from the global satellite navigation systems, the European Incurrent Scattering Radar Network, the atmospheric satellites, the lunar orbiting satellites, and other satellites. The researchers have analyzed the data collected by different devices and satellites during a solar flare event that occurred on the 6th of September in 2017. They adopted a recently developed numerical geospace model developed at the NCAR. This model, which has been called the High Spatial Temporal Resolution Magnetosphere Ionosphere Thermosphere Model, reproduces the changes triggered by solar flares in the magnetosphere ionosphere coupling system. Through the use of this model and previously collected data, the researchers were able to unveil solar flare effects on magnetospheric dynamics and on the electrodynamic coupling between the magnetosphere and the ionosphere. Information presented indicates that they observed a rapid and a large increase in flare-induced photoionization of the polar ionospheric E region at altitudes between 90 and 150 kilometers. This strange phenomenon was observed by the researchers, and they have determined a number of effects on the geospace region, including a lower Joule heating of the Earth's upper atmosphere, a reconfiguration of the magnetosphere convection, and changes in auroral precipitation. They demonstrated that solar flare effects extended throughout the geospace via electrodynamic coupling and are not limited, as previously believed, to the atmospheric region where radiation energy is absorbed. It was also noted that due to the similar solar magnetosphere ionosphere coupling process in other Earth-like planets, their research also provides new information for the exploration and understanding of the effects of solar flares on other planets. In future research, they intend to study the effects of flares on planets with the same magnetosphere. including planets such as Jupiter, Venus, and Saturn. And that, when time has passes, eventually astronomers and scientists will be looking towards observing the effects of solar flares on exoplanets as well. Like, comment, share, and subscribe. Let me know what you think about all the matters that have been discussed. Are you as fascinated as I am in relation to these solar flares and the impact that they have on the Earth's atmosphere? Thanks for watching, and goodbye.